Hello, we're going to be doing some math together. So I'm going to go ahead and get my math paper ready. So we're going to be working on chapter 13.1. So I'm going to go ahead and screen share my paper so that you can see it. And I'm going to make it nice and big. There we go. All right. So I'm going to go ahead and fold my paper into 8 squares. You guys are all experts at doing that by now. All right, so let's look at, we're writing our names at the top. And today we're going to do lesson 13.1. And this is a big lesson. We'll be in the middle of it when you're watching this recording, because there are 3 different times when we do 13.1. So we're going to do pages 204 to 207. All right. So I'm going to go ahead and open my book to 204. And we're not going to worry too much about 204, but we are going to look at 205 and 206 and 207. Okay, so let's look at page, these purple pages in your math book are activities that you do with groups of kids. So like you either do it with a partner, this says work in groups of 4. And since you're home by yourself, we won't make you do that because you don't have a group of 4. So we're going to start out by looking at number 10. So we've been talking about area, right? The area of a rectangle. And so we're going to look at figuring out the area of this particular square. Janelle bent a 36-inch wire to make a square photo frame. What is the area inside of the photo frame? Well, what we need to figure out is the length of one side. And then we're going to divide that by 4, and that's going to tell us how many inches. And then once we figure that out, we can multiply side length times width, and that's going to tell us the inside measurement. So if she had a 36-inch wire, here's our square right here. I'm just drawing it so that we can visualize it. And she has 36 inches of wire. So we're going to take 36 inches of wire and we're going to divide it by 4 so that we get the measurement of each one of the sides. And when I do that, I get 9 inches, right? So we know that this side is 9, this side is 9, and I just double checked to make sure. I looked in the book, it said it was square. This side is 9, and that means this side is 9 as well because it's a square, so all 4 lengths are the same. And so that means that we know that each side is 9 inches. Now, if we're finding the area, the formula for area is length times width. And because it's a square, we don't really have length and width. We're just going to multiply 9 times 9. So A equals 9 times 9. And that's going to give us an area of 81 square inches. And because it's area and we're noting the inside measurement, we're going to call it inches squared, right? Okay. So we're going to look at number 11 gives us 2 different methods of solving the problem. So we have a problem that looks like this. We have a drawing The length of one side of a square garden is 8 yards. Half the garden was used for growing vegetables. What area of the garden was used for growing vegetables? So we're going to figure out the area of this part right here. And there are a couple of ways to do that. There are two methods. We're going to go ahead and try the two methods. And so on number 11, I'm going to divide my space in half. And I'm going to call this method 1. And I'm going to call this method 2. Okay. And I'm just going to peek ahead and see how many problems we're doing. I think we have enough room that we can go ahead and do. I think we can go ahead and take up space and work over here. So I'm going to draw a picture. And it says it's a square garden. So I'm making that into a square. And the length of one side of the garden is 8 yards. Now, if it's a square, that means that they're all going to be the same, right? I always like to draw pictures because it helps me to visualize it. And then halfway, there are plants that are going halfway. They have more plants than me because their square is a different size in the book. But half of it has been planted. So the question is, what area of the garden was used for growing vegetables? So method 1 says that what we're going to do is half the length of one side of the square garden. So half the length. And that equals green box divided by 2. And that equals a certain number of yards. So if I know the length of the side is 8, and I'm taking half of that, I'm going to take 8 divided by 2, and that's going to give me 4 yards, right? And the area used to grow the vegetables, A equals length times width. And so we would say if this is 8 and this is 4, we're going to say A equals 4 times 8. Area equals 32. And we're going to call it yards squared. Okay, so that's one way of doing it. Another way of doing it is by finding the area of the total garden and that equals green square times 8. And that is going to equal 8 times 8, right? So the area equals length times width, and that's going to equal 8 times 8. And 8 times 8 is 64. Now that's telling us the whole garden, right? Now the part we used for growing vegetables is going to be half that size, because I can look at this and say, oh, that's half the garden. So I'm going to take 64 and I'm going to divide it in half. And that's going to give me 32 yards squared. And this is, I would probably use method 2, my own self. But method 1 works fine too, where you just go ahead and cut it in half, right? Because you know that we're using half this side. and we're using this full side. So that works fine too. Either one, either method is a good solution for figuring out the answer to that problem. Okay, now we're going to do something that is a little bit tricky. And this is always something that kids kind of tend to struggle with. And so one of the things that I like to do is I like to trace the figure onto my white paper, and I set it on top of my math book and I trace it. So I'll show you my little trick for doing this. So when you're trying to find the area of an irregular figure, then it's a little bit trickier to find. When you have partial squares, it's a little bit difficult to count the partials. So you can use rounding and estimation. So for example, if I'm looking at this whole yellow square unit, that would be worth 1 unit, right? If I'm looking at half of a square unit, that's half a square unit. If it's greater than half, so see how the yellow is almost all the way to the square, but not quite. I just round up and I say, that's a full square. If there's only a little teensy bit of yellow, I'm going to round it down to 0. So we're going to use rounding based on half. If half the square is covered, then we're going to call it half. If it's less than half, we call it 0. If it's greater than half, we call it 1. And so generally what I do, and I'll show you on the next figures that we're going to do together, I like to count. What I don't want you to do is write in your book and put marks on shapes and stuff. So I'll show you how to do it on a piece of paper. So let's look at the triangle. We're looking at whole squares. That's what we start out doing, is counting whole squares. So I'm going to grab my pointer here, my tentacle pointer. So I have 1 whole square, 2 whole squares, 3, 4, 5, 6, 7, 8, 9, 10, 11 whole squares, right? That I can see. All of these are whole squares. And then I start having half squares, right? And if I have a half plus a half, that's going to equal a whole. So I have 12 full squares. And then here I have 12 and a half, 13. 13 and a half, 14, 14 and a half, 15, 15 and a half, 16. So the area of the triangle is exactly 16 square units, because 2 halves make a whole unit. Now, this one's a little bit more tricky because I have a lot of partials on this one. Let's look at the whole squares I have. 1, 2, 3, 4. The only whole squares I have are in the middle. But look at number 5. Number 5 is almost completely orange. So is number 6. It's almost completely orange. So is number 7. It's almost completely orange. So is 8. This one right here that doesn't have a number on it looks like it's less than half. So we're going to count that as 0. Then we have 9 is almost completely shaded. 10 is almost completely shaded. This one right here is less than half, so we're going to call it 0. This one is almost completely, so it's 11, and almost completely is 12, right? So the area of the circle is just about 12 square units. And this isn't perfect, but it's pretty good, right? So we're not going to be, because we have a rounded shape and we're trying to just find the area using squares, it's never going to be completely perfect, but it's pretty close. We're not counting all of the ones that are less than, but we are counting the ones that are greater than, okay? Same thing with these two, they counted as 0 as well. Now, one way that I like to do this is I like to use my paper, and your paper is thin enough and cheap and lousy enough for us to draw it in. And so I'm going to use my drawing triangle, And I'm going to actually just lay it down on my paper. And this gives me the shape. So I have something, I have some form of reference, right? I have my shape right here. Because I can't write in my book. My teacher will kill me. Now, I also probably want to draw the fact that there is a square down the middle. There's a line right here. There's a line right here. And there's a line in the middle. Oops, my little fat thumb got in the way. So I have something that looks like this. And it looks pretty good just by tracing it. I did use my drawing triangle, so it looks pretty good. So another way to do this is to use colored pencil. That's another strategy. When you have one hole, you have 1, 2, 3, 4. So I have, oops, 1, 2, 3, 4, right? And now I'm looking at partials, and I'm going to use green to do that. This makes 5, because it's 2 halves make a whole. This makes 6, 7, and 8. And that this way I haven't written in the book at all. And I know that I have 8, and these are units, so we're going to call them 8 units squared. Okay. Does that make sense to everybody? Now let's try, we're going to draw something that's a little bit more complicated. It's going to test my drawing triangle skills. All right, so let's look at number 13. And I'm probably going to draw number 13 on its side. That way I can make it work. I want to make it fit. So again, I'm just looking through. In fact, I just turned my projector lamp on so that I could see a little bit better. So I don't know if you guys like to trace drawings or trace things out of magazines, but I love tracing stuff when I was a kid. And I even have in our classroom, I have a projector that will trace things. And I also have a projector at home so that I can trace things. If I see a really awesome drawing and I want to enlarge it and make it really big, I trace it. So I'm going to draw that line in and this line in. And then my next line is partway over. So it's right about there. And then I have another line that's right about there. And my next line's right about there. So it's looking good so far. Anyhow, having a machine that traces, a projector that traces is really fun because you can, like I've painted things on the side of my garage. I have something painted and I traced it. And on the side of my clay shed, I have traced objects. So we're going to look at this one. I did not do that great of a job with that one line. So again, I'm going to take my colored pencils, and it helps me to color them in so that I know which ones are whole squares, right? And I'm also setting it side by side with the drawing. I just don't want to draw in my book. So I know that this one is one whole. I know that this one is one hole and this one is one hole. I also know that this one, even though I did a crummy job drawing it, this is one hole. Also, this guy is one hole. Also, this, I did a super sloppy job. This is actually one hole. And the middle ones are one hole. And then this one right here. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square units, right? And then this guy is greater than, I mean, I'm looking at the actual drawing of it, and there's just a little teensy sliver left over. So I'm going to count this as number 11. This one looks like greater than, so I'm going to count that as 12. This one is definitely less than, so I'm going to count it as 0. And this one is definitely less than, so I'm not going to count those. And then this bottom one, if I'm looking on here, I can definitely see that's greater than. So I'm going to count that as number 13. And this is definitely greater than too. Look at the little white sliver. So I'm going to count this as 14. And so these guys are my partials. So I end up having 14 square units. Okay. And what kind of ends up happening is that this lines up with this, right? If you were to actually draw this in, and you could take this piece, turn it around and make it into a square. You could take this piece, turn it around and make it into a square. So they kind of go together. And then you have a little bit extra here. So it's close to 14 units. It's not perfect, but it's pretty good. And that's kind of what you're looking for. It's never going to be perfect, but you want to get as close as you can. All right, let's look at the next one. I'm also going to go ahead and draw this one with my drawing triangle. So this looks like a little house. I have this. This tests your ability to hold your drawing triangle evenly without moving it. And then there's this. And then there's this on the bottom. I need an extra pair of hands. Percy, come help me. He has paws. He couldn't help me, huh? He'd try. And then I have this. And then I have this. And then I have this coming up too. Boop. And you don't want to draw too hard in the book either and leave a line. So I'm just gently drawing it, not drawing it like a maniac and pushing really hard. And then I have a line that's going to come right across here. I have a line that goes right across here at the chimney. I have a line that goes right across here at the roof. And then I have a line right here that's really hard to see. I ordered new glasses because I'm really having a hard time seeing, and they're gonna arrive, but they haven't arrived yet. And then I have a line here. And it's kind of hard to line that up with the graph because I think they put it right on the bottom of the graph paper. That's why. Stupid math. So I have a line right here, and then I have one here, and then I have this here. This comes down here. Okay. Ah. Jinkies. Okay. So I have sort of like a doppelganger. I have a double of what is in the book. So I don't have to write on the book and go 1, 2, 3, 4 with my pencil on the book because kids have done that before. And then I have to do karate on them. So here we go. I have 1, 2, 3, 4, 5, 6, 7. That's a full one, even though my line is a little off. 8, 9, 10, 11, 12, 13, 14, 15. And then I have this and this, and this and this. So if I'm coloring in all the ones that I have just straight up, I have the chimney, most of the roof, and then I have the whole house below. And then I have halves, right? If you have halves, 2 halves make a whole. So if they're perfectly in half, you can start piecing the halves together. And this is a pretty, coincidentally, this one has 4 halves, and 4 halves makes 2 wholes. So this becomes, if I have 15, this becomes 16, and this becomes 17. So I have 17 units squared. And that one's perfect. It's not like this one where I have little slivers. So if you have halves, a half is a nice, good, clean cut. So if you have 2 halves, you can put them together to make a whole. What's really tricky, and I like that this math program doesn't really do this. Oh, there's going to be a hard one coming up pretty soon tomorrow. But sometimes you will see our old math program, and also the math program at my old school, did stuff like this on a grid. And so you end up with all these little tiny pieces, right? You have like this little piece right here, and this piece here, and little slivers here. And it just makes it really hard because you have lots of little tiny, you have this little tiny piece. Well, if I took 2 little tiny pieces, I could add them to the big piece and make a whole. So I like how this math program is just saying, hey, if it's less than half, call it 0. If it's greater than half, call it 1. Don't worry about putting all the pieces together like a puzzle. Just get close and estimate it. So I hope this helped you to learn how to measure area when you have kind of in an irregular shape, something that's not exactly perfectly square. All right, so thanks for joining me, and I will talk to you later.